Imagine you are building an user registration API. Everything is working perfectly on your local machine. You create a controller, connect it with a service layer, save data into the database, and finally deploy your application into production. Now imagine a user sends the following request. The name field is completely empty, the email field is not even a valid email, and the age is -10. Now tell me honestly, should Spring Boot allow this request and save it into the database? Absolutely not. Because once invalid data enters into your application, the damage has already started. You might end up sending emails to invalid email address. You might end up generating reports based on incorrect data. And in some systems like banking or healthcare applications, bad data can create a very serious business issues. This is exactly where validation comes into the picture. But today we are not just learning validation annotations. Today we will understand what validation actually is, how @valid works internally, who executes validation, why Hibernate Validator is required, what is @validated annotation, how validation exceptions are generated, why @valid sometimes doesn't work, how validation is implemented in real world Spring Boot applications, and what is constraint violation. And at last, we will be revising the concepts. By the end of this video, you will understand validation from beginner level all the way to the production level. So what is validation? Validation is the process of checking whether incoming data satisfies predefined business rules before your application start processing it. In simple words, validation acts like a security guard. Before data enters your business logic, validation verifies whether the data is acceptable or not. Let's take a very simple example. Suppose you are building an employee management application. For every employee request, the name should not be empty. Email should follow the valid email format and age should be greater than 18. Or even we can say that age should be between 18 to 60. These are business rules. And validation ensures that every incoming request follows these rules. Now, many developers think validation is just about annotations like @not null or @not blank. But validation is actually much bigger than that. To understand validation properly, we first need to understand what happens without validation. Let's imagine validation doesn't exist. A client request comes to your application, the controller receives the request, the service process the request, and the repository save the request to the database. And finally, invalid data reaches the database. This means the database now contains a corrupted records. Once bad data enters the database, fixing it becomes expensive and sometimes even impossible. That's why experienced developers always validate data before processing it. In software engineering, there is a famous principle called garbage in, garbage out. If invalid data enters your application, invalid results will eventually come out. So, validation prevents this problem. Now, here is a question that many Spring Boot developers don't know. Is validation actually a Spring Boot feature? The answer is no. Validation does not belong to Spring Boot. Validation comes from something called Jakarta Bean Validation. Jakarta Bean Validation is a specification. A specification simply defines rules and standards. It says how validation should work, but it doesn't actually perform validation. Think about like a driving rule book. The rule book defines the traffic rules, right? But the rule book itself doesn't stop vehicles, right? Similarly, Jakarta Bean Validation defines validation standards, but it doesn't execute validation. So the next question becomes very interesting. If Jakarta Bean Validation only defines rules, then who actually perform validation? The answer is Hibernate Validator. Hibernate Validator is the most popular implementation of Jakarta validation. It contains the actual logic required to execute validations. When you write annotations like @not blank, email, size, the real work is ultimately performed by Hibernate Validator. Now, another important question arises. How does Spring Boot knows about Hibernate Validator? The answer is Spring Boot auto configuration. When we add the validation dependency into our project, Spring Boot automatically detects Hibernate Validator and it integrates it into the application context. Because of this integration, validation starts working almost magically. But remember, it is not a magic. Behind the scenes, Spring Boot is configuring and wiring everything automatically. So if you see this flow diagram, developer use at the rate not blank email at the rate min annotations. Internally, it will call Jakarta bin validation specification, where we will be using Hibernate Validator implementation, and these things will be auto configure inside the Spring Boot. So whenever somebody asks you what validation is, don't say validation means at the rate not null. Validation is actually a complete mechanism involving Jakarta validation, Hibernate validator, Spring Boot auto configuration, and request processing. Understanding this architecture is very important because in the next section, we are going to see how annotations like at the rate not null, at the rate not blank, and at the rate email actually work internally. And after that, we will go even deeper and understand how at the rate valid works behind the scenes when a request enters a Spring Boot application. Now that we understand what validation is, why it is required, and how Spring Boot integrates with Hibernate Validator, let's move to the practical side of validation. Because ultimately, validation starts with validation annotations. And these annotations are something every Spring Boot developers use almost every day. Let's start with most common one, at the rate not null. When we use at the rate not null, we are simply telling the validation engine that this field should never contain a null value. For example, if I have a field called name and I annotate it with at the rate not null, then the request will fail whenever name is null. But here is something interesting. Many developers think at the rate not null also checks empty string. That is completely wrong because not null only checks the null value, nothing else. This is where another annotations comes into the picture, and that is at the rate not empty. Not empty performs two checks. First, it checks whether the value is null. Second, it checks whether the value is empty. So now null also fails as well as empty string also fails. But there is still a problem. Suppose somebody sends a value containing only spaces, means white spaces. For example, three spaces. Will at the rate not empty fail? No, because technically that string is not empty. It contains characters for empty spaces. And that's where the most commonly used annotations comes into the picture. And that is at the rate not blank. At the rate not blank checks three things: null, empty string, and strings containing only white spaces. Which means at the rate not blank is usually the best choice whenever we want mandatory text input. This is why in real projects you will see at the rate not blank much more frequently than at the rate not null. Now let's move to email validation. Suppose we have an email field. We don't just want some random text. We want a properly formatted email address. That's where at the rate email comes into the picture. When we use at the rate email, Hibernate Validator verifies whether the provided value follows a valid email format. For example, abc at the rate gmail.com. It will pass. But abc.com, it will fail. abc, it will fail. And an empty invalid value also fails if combined with at the rate not blank. Now let's move to another important annotation, and that is at the rate size. At the rate size allows us to define minimum and maximum length. For example, a password should contain at least 8 characters and maybe at most 20 characters. This can easily be achieved using at the rate size annotation. Let's understand min and max. Suppose a should always be between 18 and 60. So we can simplify to at that min 18 and at that max 60. Now the validation engine automatically verifies whether the incoming value satisfies these rules or not. Next, let's look into at that pattern. This annotation is extremely powerful because it allows us to validate data using irregular expressions. For example, mobile numbers, PIN code, employee code, passport numbers, anything that follows a specific format can be validated using at the rate pattern. Now let's stop for a moment and ask a very important question. We are writing all these annotations, but who actually executes them? These annotations don't contain validation logic themselves. They are just metadata. The actual validation logic is executed by something called constraint validators. Every validation annotation is backed by a validator implementation. For example, @not blank is backed by an internal validator class. When validation starts, Hibernate Validator discovers all constraints present on the object. Then it executes the corresponding validator implementation. This means validation is not magic. It is simply a collection of validator classes executing predefined rules. Now let's move to the most important part of this entire masterclass, that is how does @valid works internally. Because almost every Spring Boot developer uses @valid, but very few understand what actually happens behind the scenes. Let's look at a simple example. Suppose we have a controller method. The request enter into our application as a JSON data. The first component that receives every request is dispatcher servlet. Dispatcher servlet acts as the front controller of Spring MVC. Every incoming request first reaches to the dispatcher servlet only. Then dispatcher servlet identifies the appropriate controller method, means which controller method should be executed. Now the request body is still JSON. Spring cannot validate JSON directly. First, it needs to convert JSON into Java object, and this conversion is performed by Jackson. Jackson takes the incoming JSON and creates a user DTO or Java object. Now we finally have a Java object ready. At this point, Spring notices something interesting. The parameter contains an annotation called @valid. The moment Spring sees @valid annotation, it delegates the object to the validation engine. The validation engine is powered by Hibernate Validator. Hibernate Validator starts scanning every field. It discovers @not blank, email, @min, @pattern, whatever annotations you have added. Then corresponding validator implementation starts executing. And each validator checks its own rule. If all validators succeeded, then validation will be success. And only then does execution continue into the controller method. This means your controller method executes only after the validation succeeds. Now let's imagine one validation fails. Maybe email format is wrong or age is less than 18. The validation engine immediately stops normal execution. It creates validation errors. And eventually, Spring throws an exception. And that's exactly what we are going to understand through the coding. If you see here, this is my request DTO class and I have the various field added over here. And then I have added the required annotations to this field where I have a create API. And then into the method parameter, apart from request body, I have added one annotation @valid. Now if any validation fails for this user request DTO, this line will never get executed. Only this line will get executed if all the validation get passed. Now I have already executed or started my application. Let's try to trigger a request or send a request from Postman for the different validation and see how it behaves. First, I'm passing all the required fields and hitting the request. If you see here, validation successful and data saved to the database. Now let me remove this name field and pass it as empty. This time also it says validation successful, data saved to database. But this should not be the case, right? Which means that not null is not checking the empty string. So I have used not empty into the department. So now this time let me remove the field from department, just pass an empty string and see the behavior. Now you are seeing bad request. So if I scroll down and see the actual error, if you see here, department must not be empty. And what kind of exception it is throwing, let's see. So the exception is MethodArgumentNotValidException. And also we are receiving 404 bad requests. So for location, I have used @not blank. We should check empty, white spaces and null. So if I remove Pune, it should throw error. Method argument not valid exception. And then at last it says location must not be blank. Let me put some white spaces. So 1, 2, 3. Now let me hit the request. Same. Says location must not be blank. And if I'm removing this field completely, this time also it should throw error or exception. Again, it says that location must not be blank. So we can conclude that not blank checks three things: null, empty string, and white spaces. Now let me give the age value as 2. See here, method not valid exception again thrown, and if I go at last, age must be greater than or equal 18. Now if I'm giving the wrong email as just some word, this time also it should get failed. Again, if you see here, and it says email must be well formatted email address. So this is how validation works in Spring Boot. Now, if you might have noticed the controller method, we have added @valid. So if we remove this @valid annotation, then validation will never perform. So let me run this application again and hit any request. So application is started. If you see, I have removed that @valid annotation from here, and from the postman, if you see the email field, I have given the wrong value, only IntelliGuru dot. So this time if I send the request, it's saying validation successful and data saved to the database. Means like validation is not being performed actually. Since we remove @valid, so validation is not performing, and I have just hard coded this value, that's why it is giving this response. So when we remove @valid annotation, validation will never perform. Apart from using @valid annotation in the request parameter, there is one more approach to implement or achieve the validation. So if you see in this method, I didn't pass @valid annotation as like to the previous method. What I have done here, I have created one validator utility class. Inside that, I have created one validate user method. So if you see here, I have defined one field called validator. And inside our validate user method, when I'm calling validator.validate by passing user.due as method parameter, Hibernate Validator checks all constraint and returns a set of constraint violation objects. Each constraint violation represents one validation failure. Now here is the interesting part. When we use @valid in Spring Boot, we don't write this code ourselves. Spring internally calls validator.validate method for us and processes all the constraint violation object automatically. But since we are checking the validation manually, so we are adding these lines of code. So if you see here, we have the set of violations, and then we are checking if the violation is not empty. If violation is not empty means some error is there. And then we are looping through this violation and printing that particular error message or validation message. Here you can also add those error messages and error path into some list, and you can return to the REST API. So this is how we can achieve that validation manually using validator. Now let's discuss another important topic, @valid versus @validator. This question appears in interviews very frequently, and most developers believe both annotations are identical, but they are not. @valid comes from Jakarta bean validation, which we have learned already, but @validated annotation comes from Spring framework. Both triggers validation. However, @validated supports validation groups. Now let's understand validation groups, because this is where @validated annotation becomes useful. Imagine a user management application. For user creation, name field is required, email field is required, and password field is required. But for user update, only name and email is required, password is not required. So now we have different validation rules for different operations. Means for create operations, we require 3 fields. So different rules are there. For update operation, we require only 2 fields. So this scenario cannot be handled easily using only @value. This is where validation groups helps us. We can create separate groups something called create user group or update user group. Then specific validation rules can be attached to the specific groups. And finally, @validated allow us to choose which group to be executed. This is one of the most practical uses of @validated in real world applications. Let's see this functionality in our IntelliJ in the code. If you see here, I have created two groups. One is create user group, second one is update user group. And this is nothing but an interface. And then inside my user DTO, I have added three fields: name, email, password. As we discussed recently, during user creation, we need name, email, and password. But during user updation, we don't need password. This might be optional. So during updation, we need only name and email. So if you see here, I given @not blank means name should not be empty or blank. And then I'm calling the groups. Since this name is required during creation and updation, so I'm calling both groups and I'm giving message name is required. Same thing is applicable for email as well. But if you pay attention over here, you will notice that I'm not calling update user group. Means this password field is not required during update. And inside the controller method, I have created two API. One is for create user, one is for update user. If you notice into the create user, I am calling @validated annotation. And inside this annotation, I am passing create user group.class. During update call or put call, I am passing update user group.class. So let's run this application and test the behavior from Postman. So application is already started. Let me go to the collection. So first I'm passing all this field and hitting a request. See here it says user created and we receive a success response. Now what I'm trying to do, I'm removing this password field. Let me hit the request again. And this time, bingo, we receive a 400 bad request error. So let's see that error. You will notice that method argument not valid exception. And then it says validation failed for argument. Given password is required during user creation. So here also it says password is required during user creation. Now let me keep the password and remove this email. I'm sending the request again and we again got the error. And if you see this error message over here in our console, you will see that email and message is email is required. So which means that our create user group is working as expected. Now let me go to that update request and hit a request. So if you see here, I didn't pass that password field in this update call. So I'm going to hit a request. See, it says user updated and I got 200 OK means success response. So this time password is not required and then our validation successfully worked for name and email. So this is how user group works along with @validated annotations. Now let's discuss nested validation. Suppose user DTO contains address DTO field or address DTO object. Even if user DTO has @valid annotation, address DTO validations will not automatically execute. To validate nested object, we must explicitly place @valid on the nested object field. This is very common mistake in real projects. What if you see here inside this user request DTO, we have one field called user address DTO and here we have added @valid. If we are not adding @valid annotation over here for this user address DTO, the validation inside this user address DTO for all these fields will never happen. That's why to perform the validation in the nested object or nested classes, we need to annotate @valid for those classes. Understanding these small details is what separates a beginner from an experienced Spring Boot developer. Now let's move to production level best practices. The first thing every professional project should implement is custom validation message. For example, name cannot be blank, email format is invalid, age must be greater than 80. These messages makes APIs easier to consume. Now let's discuss one of the most searched Spring Boot interview question, and that is, why is @valid annotation not working? The first reason is missing validation dependency. Next would be forgetting to place @valid on controller parameters or missing @valid on object. Third would be importing the wrong annotation package. Fourth would be forgetting @valid on nested object that we discussed earlier. And the final would be misunderstanding validation groups. So these are common mistakes that might cause @valid not working. Now let's understand the production best practices. Always validate request DTO, never validate entity classes directly. You should always keep validation rules inside DTO class only. Create global exception handling. This we'll be looking into next video. Next would be return consistent error response. Next is never expose internal exception details. Instead of you wrap that exception details with an understandable message. And the final would be keep validation messages meaningful. So these are the points that you should keep in mind for production best practices. Now let's see few important interview questions from the validation. So those questions are, what is validation? Difference between @not null and @not blank. How does @valid works internally? Difference between valid and validated. What is Hibernate Validator? What is method argument not valid exception? What are validation groups? Why is @valid not working? If you answer these questions confidently, you are already ahead of many Spring Boot developers. Now, let's summarize everything we have learned today. We have learned validation ensures only correct data enters to the application. And then we look for Spring Boot validation is based on Jakarta validation. We also know Hibernate Validator executes validations, not the annotations. We have also seen annotations like not blank, email, min, max define constraints. @valid triggers validation execution. And then we have seen dispatcher servlet receive request. After that, Jackson converts JSON into Java object. Hibernate validator executes constraint. Validation failure generates method argument not valid exception. And @validated supports validation groups. Using the validation groups, we can perform the validation for different rules. And finally, production applications should always implement proper validation and error handling. If you truly understood today's video, you now understand validation not just from a coding perspective, but from an internal working perspective as well. And in the next masterclass, we will go one level deeper and understand exception handling in Spring Boot, where we will learn how Spring Boot catches exception, generates response, and how global exception handling actually works internally. Thank you for watching. Follow for more videos.